Hooke's law says that stress is directly proportional to strain within proportional limit. So what is the importance of that? Let us see now. So whenever you are listening this word, stress is directly proportional to strain. Are you getting any doubt? In the previous videos, we have discussed that normal strain or tangential, like different strains we have discussed. Different stresses are also present. About that stresses we will discuss after this. Okay. Now, stress is directly proportional to strain. So is it valid to all stresses? Let us see. So we are going to talk about two things. Two. Number one, stress. That stress regarding normal. Next one, tangential. Tangential. So a normal stress, try to apply these Hooke's law here and here. అప్పుడు ఏమర్థమవుతుంది చూడండి. Stress is directly proportional to normal stress is directly proportional to normal strain. Shear stress is directly proportional to shear strain. So proportionality ni remove cheyadaniki proportionality we will keep one equals and constant. అలా చేస్తే ఏమొస్తుంది? Stress equals to some constant E and epsilon. Then if you want to know what is a strain, what you can write? Stress by that constant value. What is that constant value? Here, what is E is Young's modulus. Young's modulus or modulus of elasticity. Modulus of elasticity. How this helps us? ఈ వాల్యూ అసలు ఎలా హెల్ప్ చేస్తుంది? ఎలాస్టిసిటీని ఎలా హెల్ప్ చేస్తుంది? You can see this. Stress is directly that relation. Just if you want to understand, let us write this in another form. Stress to strain ratio is equals to that constant. If you apply some laws here to understand, you can see the relations. What is that? If E value is more, what will be the stress and strain? Can you guess from that relations? Stress and strain. So if you see there, the stress is directly proportional to E value. That's why if stress A value is more, stress is more, strain is very less. And if E value is less, stress value is less and strain value is more. Because directly proportional and inversely proportional, that relation you can see from this equation. If you want to understand that, what is the meaning by taking two materials as example, we will try to understand that now. Let us go to the shear. Shear stress is directly proportional to shear strain. That is tau is equals to some constant into pi. What is this constant? G. Stress, shear stress by shear strain. This value again similarly gives the idea what happens to the shear stress and shear strain. First of all, let us know what is G value here. This G value is modulus of rigidity. Modulus of rigidity or shear modulus. Shear modulus. Shear modulus. So this value again with respect to the strain and stress, if you want to talk, you can do like this. If G value is more, tau value can be more, but pi value can be very less. Because here with respect to G, how is the tau value and pi value? You can concentrate. And now if G value is less, pi value will be more and tau value will be less. What is the meaning of this? అసలు ఏంటి ఈ వాల్యూస్ ఇచ్చాము, ఓకే ఎక్కువ అంటున్నాం తక్కువ అంటున్నాం ఎలా? Okay, now I will give two examples to understand. Suppose I have a solid here like this. I'm extending by the tensile force like this. Will it have more strain or stress? If you want to know that, just simply enough, these materials E value is what? Young's modulus value is what? If you know, you can answer that question. Will that have the more stress or more strain? So that's why it is needed to understand. Okay, let us see. MS, mild steel గురించి ఆలోచిస్తే approximately we give 230 to 250, it will be just I'm taking 240 megapascal. 240 megapascal. Then what is that meaning? 240, okay, into 10 to the power of 6 Newton per meter square stress is there. That can be the bearable stress by the mild steel. If you take plastic, if you take the plastic, that it's only 14 megapascal. What it means? 14 into 10 to the power of 6 Newton per meter square. Okay, that the same relations what I have spoken just now. Can you apply here? Stress, strain అని ఇక్కడ మైల్డ్ స్టీల్ ఎక్కువ స్ట్రెస్ ని బేర్ చేస్తుందా, ప్లాస్టిక్ ఎక్కువ స్ట్రెస్ ని బేర్ చేస్తుంది? మైల్డ్ స్టీల్ లో స్ట్రెయిన్ ఎక్కువ ఉంటుందా, ప్లాస్టిక్ లో స్ట్రెయిన్ ఎక్కువ ఉంటుంది? You can see that. Is that true what we have discussed here? Example, right? That example, these mild steel and plastic too, you can compare with this above discussion. E value is more stress capacity, right? That 1 2 1 2. Similarly, shear modulus value G also gives us the idea that is that material going to bear more stress, shear stress, not simply stress or nervous stress. Is that material going to bear more shear stress or shear strain? Shear strain. So imagine this, if G value of the material is very less, very less. What can be greater? Pi can be greater. So how can you imagine that? How can you understand that first? You try to imagine this. ఇంతకుముందే మనం వీడియోలో కూడా డిస్కస్ చేస్తాం. If I apply a force, like this, shear force, right? Shear force I'm applying. What happens? It tries to get the deformation like this, right? So what is the pi? Shear strain. Is it going to be more or less? Okay, imagine that. If I place here ఇదే షేప్ లో ఉండే ఒక బాక్స్ ని నేను టూ మెటీరియల్స్ ఇమాజిన్ చేస్తున్నా. వన్ ఈజ్ వుడ్, అనదర్ వన్ ఈజ్ రబ్బర్, అనదర్ వన్ ఈజ్ స్టెయిన్లెస్ స్టీల్. If I have placed like these three boxes and I'm applying the same shear force, but which one will give the more shear deformation? Can you guess? Simple answer is whichever is going to have less shear modulus or modulus of rigidity, that is going to give the more shear deformation. So like this, we are going to understand the relation of these constant values with the rest by discussing this Hooke's law, right? These Hooke's law gives us the complete idea by just the constant values how the stress strains can be more or less. Okay,